All right, you are welcome again. Today we want to talk about relativity, and let's consider this question. Observers O and O prime approach each other with a relative velocity of 0.6 c. If O measures the initial distance to O prime to be 20 meters, how much time will it take as determined by O before the two observers meet? How much time will it take as determined by O before the two observers meet? Okay, this is a physics question under relativity. So I have two observers coming closer to each other. The first person takes the measurement from the second observer, and the distance happens to be 20 meters. And then they are asking us, how much time will it take as determined by O before the two observers meet? Okay, now let's go. The formula we're going to use here, we're going to say that the time dilation is equal to distance all over velocity. Hello? We're going to say that time dilation here is equal to distance all over velocity. So here, based on the information given to us, we have the distance and we have the velocity, right? So we're going to say it's equal to d all over v. And then we have our distance to be 20 all over the velocity is 0.6 c, right? Good. Now, what is c? C is the speed of light. Okay? Yeah. Now, let's go. Let's fix it in. We're going to have 20 all over 0.6 times the speed of light, which is 3 times 10 raised to power 8. So when we say 0.6 times 10, when we say 0.6 times 3 times 10 raised to power 8, what is it going to give us? It's going to give us 1.8 times 10 raised to power 8. So when we say 20 divided by 1.8 times 10 raised to power 8, it's going to give us 1.11 times 10 raised to power 7 seconds. Okay, so this is the amount of time it will take for the two observers to meet. Okay, yes. Now let's take more examples.